Hello class, this is Amy Hohers, your professor. I apologize that I can't be in class this morning, but I thought the next best thing would be if I could go over this review with you so that you had the information for the test on Monday. So we're going to start with this first question regarding the formula for a falling object. And it asks the distance in feet of a falling object after t seconds is d equals 16t squared. And we want to know how far the object will fall after 3 seconds. So the distance would be equal to 16 times the time, which is 3, squared, which will be equal to 16 times 9, which is then equal to 144 feet. So the object after 3 seconds, we insert that in here for t, we substitute that in, and we get 16 times 9, and so the object after 3 seconds will have fallen 144 feet. Now the next question is very similar, except we want to do 6 seconds. So the distance after 6 seconds would be 16 times 6 squared, or 16 times 36, which equals 576. And so after 6 seconds, it's fallen 576 feet. So the next question asks you to kind of analyze that. They want to know, did doubling the time simply double the distance? Well, if we look at this amount compared to this amount, 576 is more than double 144. Double of 144 would only be 288. So something more is going on there. When we doubled this time, we didn't just double the distance. So the answer is no. And so the question next is, why is it not just doubling the time? Or I'm sorry, doubling the distance when we double the time? Well, the answer to that, or the key to that, is the fact that this formula has a square in it. And so instead of just taking times 3 and times 6, we're actually taking times 3 squared and 6 squared. And that square causes this number to go up more than if you just doubled the number itself. In fact, if you look between 9 and 36, we've actually multiplied by 4 times instead of 2 times. And that's because we basically did twice squared, which is actually 4 times. So we've actually taken the distance times 4 rather than simply doubling it. Now, as far as on the exam, what I'm looking for is for you to acknowledge or notice that it's squared. So you could have said, for why, you could have said because the time is squared. That would have been sufficient and fine to put for an answer there. Now, the last thing that we want to do on this question is we want to rewrite the equation so that the t is alone, and we could put in a d to find t. We want the equation so that it's a t equals equation. So we're going to start with d equals 16t squared. And we're trying to get rid of everything on the right side so that this just has a t. So the first thing I have to get rid of is this 16. And I'm going to do that by dividing because this is a multiplication. But of course, anything I do to the right side, I have to do to the left side. So I get d over 16 there, and these cancel. So in my next step, I have d over 16 equals t squared. And so the only thing I have left to get rid of is this square. Well, the inverse operation of a square is a square root. So if I take the square root of both sides, I get the square root of d over 16 now equals t. And I can just leave it like that. That would be fine for an answer. It's sometimes preferable to put the single variable along on the left side. And also in this case, since it's the square root of this entire thing, I could take the square root of 16 if I wanted to. So this is sufficient. This is fine. But I could also write it just a little bit better by saying t equals the square root of d over 4. And that's it for that problem. So on the next problem, we are going to be looking at Widmark's formula. And if you recall, this is the formula for blood alcohol content. And I apologize, this is the best way I could find to be able to write on the document. So we have this formula that says B equals negative 0.015 T plus 2.84 times N over W times G. And we have all the description of what each of those variables is. The B is the blood alcohol content, N is the number of drinks, W is the person's weight. We have this gender constant, which is a little different for men and women. Men, on average, metabolize alcohol faster than women do. And T is the number of hours since the person had their first drink. So if you have a female and she weighs 140 pounds, she's had 6 drinks, and it's been 3 hours since she started drinking, we could calculate her blood alcohol content. So her blood alcohol content would be B equals negative 0.015, and then we're not going to put in T because we know T. T is 3 hours. So I'll go ahead and put a 3 in here. And then 2.84 is a constant in the formula. The N I also know because N is the number of drinks, such that she's had 6 drinks. And we're going to divide that by her weight, which is 140, times her gender coefficient, since she's a female. We're going to use the gender coefficient for women and put in 0.55. Now, if we calculate that out, we have to be careful. You can do it in parts. You could go ahead and do the 2.84 times 6 and the 140 times 0.55 separately and get those numbers. If you did want to put it into your calculator straight across, you would have to remember to put parentheses here and here. So I'm going to do it that way, and I'm going to take negative 0.015 times 3 plus parentheses 2.84 times 6 parentheses divided by 140, divided by parentheses 140 times 0.55 parentheses. And if I calculate that correctly, and you want to try typing that in your calculator, make sure it's working for you, okay, you should get 0.176 approximately. Now, we know from our discussions that that's over the legal limit. So if she were to drive and get stopped, she would be charged with a DUI. So how much total time will she need so that her blood alcohol content is below the legal limit? So we'll calculate when it will be at the legal limit, and then anytime after that, she should be okay. Now, in this case, we know the B, and it's the time that we are unsure of. So we're going to rewrite this equation with the B being 0.08 and the T being replaced with a variable. And then over here we have all the same numbers. The 2.84 is a constant in the equation. She still had 6 drinks. She still weighs 140 pounds. And we still are going to use the coefficient, the gender coefficient or constant for her being a female. And if we calculate that all out, in this case, it would have actually been helpful if on the prior step we would have kept this calculation, because now we need that. And I need to figure out just this amount, because I can't do this part because it's got that variable in it now. So if I calculate just parentheses 2.84 times 6 parentheses divided by parentheses 140 times 0.55 parentheses, I get approximately 0.22. So I'm still trying to get this T alone, so I'm going to subtract 0.22 from the right side, which means I have to subtract 0.22 from the left side. So 0.08 minus 0.22 gets me negative 0.14. We'll start again up here. And that will equal negative 0.015 T. So I still need to get this T alone, and I still have this negative 0.015 in the front. So I'm going to divide by that, because to undo a multiplication we divide. And this will give me my amount of time that she needs to wait. So I'm going to take negative 0.14 on my calculator, and I'm going to divide that by negative 0.015. I could just leave the negatives off because they're just going to cancel each other. But if I compute that, I actually get 9.33. So she needs to wait more than 9 hours before she will be legally safe to drive. If you calculate, that's 1/3 of an hour, so it's about 9 hours and 20 minutes. But for what we're doing, if you just left it as 9.33 hours, that would be fine. Okay, so I'm going to stop the video now because I'm almost out of time. I can only do 15-minute clips. I'm going to stop now, and I'm going to start another clip, and we'll pick up with number 3 in part 2.